Good afternoon, good morning students. So, now in the last class I started the chapter definite integral. So, I explained the concept of definite integration and also I explained the difference between indefinite and definite integration. So, what is indefinite integration? That is f of x dx is equal to q of x plus c. So, a to b f of x dx is equal to q of b minus q of a. So, this is definite integral, this is indefinite integral. What is the difference between definite and indefinite integral? In indefinite integral c is there, so the value is not definite. In the second case, that is definite integral, value is definite, so I will be getting qb minus qa, so no arbitrary constant. So, this I explained in the last class and also I considered 7 problems. In all the problems I take only algebraic terms x square e power x like that. Now, I am going to take in the integrand all trigonometric functions, So, consider problem number 8, 0 to pi sin of x by 2 cos of x by 2 variable of integration dx. 9th problem 0 to pi by 4 tan power 5x secant square x dx. So, 10th problem integration of 0 to pi by 3 secant x tan x dx. See here, so what I explained in indefinite integration types, basic type, substitution method, integration by parts and 7 forms, 4 forms of standard integrals. So, I am going to consider the problems of the same type and giving upper limit and lower limit, those problems indefinite integration. So, if limits are there, the given problem come under definite integration. So, 8th problem. Now, I is equal to integration of 0 to pi sin of x by 2 cos of x by 2 dx. All half angles are there, half angles x by 2 and x by 2 half angles. Now, there is one result, that is sin 2x is equal to 2 sin x cos x, multiple angle formula with respect to sine function, Now, replace 2x by x and x by 2 in the multiple angle formula. So, you will be getting half angle formula. So, replace 2x by x, sin x is equal to 2 sin of x by 2 cos of x by 2. See here, sin 2x is equal to 2 sin x cos x, multiple angle formula with respect to sine function. In this formula, if you replace 2x by x and x by 2, so I will be getting half angle formula, that is sin x is equal to 2 sin x by 2 cos x by 2. What is the integrand? Integrand is sin x cos x by 2, sin x by 2 cos. So, 2 is extra transferred to this side, that is half into sin x is equal to sin of x by 2, so cos of x by 2. So, half sin x is equal to sin x by 2 cos x. Therefore, we can replace sin x by 2 cos x by 2 by half sin x. Half is a constant, take it outside, 0 to pi sin x dx, Now, half into what is the integral of sin x with respect to x, that is minus cos x between 0 to pi, or we can take minus half as common factor. So, apply only for variable, that is cos pi minus lower limit cos 0. cos pi upper limit minus cos 0 lower limit. Cos pi, what is the value of cos pi? See here, cos of 180 degree, pi means 180 degree is equal to, using allied angle property we can write cos 90 plus 90. So, 180 degree second or third quadrant cos function is negative, therefore, that is minus cos changes to sin 90. So, if theta is added or subtracted from 90 degree, all t functions change into their corresponding coratios. Here cos function changes to sin function, and in case of cos 180 second or third quadrant, so in both the quadrant cos is negative. So, therefore, minus sin 90 is 1. So, cos 180 value is minus 1, cos 180 value is minus 1. So, minus of into cos pi is minus 1 minus cos 0 is 1, cos 0 is 1, or this is equal to minus of into minus 1 minus 1 minus 2, 2 cancel, minus into minus plus. So, this is the definite value of the given definite integral, that is 0 to pi sin x by 2 cos x by 2 dx is equal to 1. Now, next problem. Zero to pi by 4, 0 to pi by 4 tan power 5x secant square x dx. Now, observe the integrand. The derivative of first function is exactly second function. Derivative of the first function, that is tan x derivative is secant square x. So, this problem is under the type, that is f of x f dash x dx. So, the problem can be solved by substitution method. In substitution method, the problem is of the type integral f of x f dash x dx, that is first function derivative is exactly second function. Therefore, you must take substitution for f of x, substitution for the first function. See here, put tan x is equal to, t, put tan x is equal to t. Tan x differentiation is secant square x, that is t differentiation dt by dx. Secant square x is equal to dt by dx, or we can also write this as cross multiplication, secant square x dx is equal to dt, secant square x dx is equal to dt. Now, the given integral becomes, given integral 0 to pi by 4, tan power 5x means t power 5, secant square x dx is dt. So, t power 5 dt. So, that is equal to integration of t power 5 with respect to t. So, observe this formula, integration of x power n dx is equal to x power n plus 1 by n plus 1 plus c. If you change the variable, the value of the integral remains same according to property of definite integral. So, I change the variable from x to t. This method is also called as change of variable method. Now, integration of t power 5 is t power 6 by 6. So, according to the formula. So, between the limits 0 to pi by 4. Now, substitute back for t. T stands for tan x, tan power 6x, 1 by 6 is a constant, take it outside. So, between 0 to pi by 4. Now, substitute back for t, t stands for tan x. So, t power 6 is tan power 6x, 1 by 6 is a constant. 1 by 6 into apply upper limit, that is tan power 6, x is pi by 4, minus tan power 6 0, so lower limit. So, what is tan pi by 4? Value of tan 45 is 1. So, 1 by 6 into 1 to the power of 6. What is tan 0? Tan 0 is nothing but sin 0 by cos 0, sin 0 degree by cos 0 degree. Tan 0 degree is equal to sin 0 degree by cos 0 degree. 0 by cos 0 1, 0 by anything is 0, minus 0 to the power of 6 or 0. So, which is equal to 1 by 6 into 1 power 6 is 1. So, totally final answer is 1 by 6. So, this is a definite value of the given integral 0 to pi by 4 tan power 5x secant square x dx. So, this is the problem of the second type, that is integration by substitution. So, what I consider the problem number 8 here, that is basic method problem, basic method. So, this is substitution method problem. So, 10th problem, problem number 10, I is equal to 0 to pi by 3, 0 to pi by 3, pi by 3 or 60 degree, this is in radians, pi by 3 radians. If you want to express this in degrees, pi is 180 by 3, 60 degree. So, 0 to pi by 3 secant x tan x, secant x tan x dx. So, direct integration, that is basic method, basic method. What is the integral of secant x tan x? Integration of secant x tan x is secant x. So, between the limits 0 to pi by 3, 0 to pi by 3. Now, apply upper limit, apply upper limit, secant pi is x is pi by 3 minus secant 0. Secant 60 degree, that is 1 by cos 60, secant 60 is 1 by cos 60, cos 60 is half, reciprocal of is 2, that is secant 60 value is 2. See here, what is cos 60? Cos 60, that is equal to half, cos 60 is half, secant 60 is 1 by cos 60, that is 1 by 1 by 2, that is nothing but 2, secant 60 is 2 minus secant 0, reciprocal of cos 0, 1 by cos 0 is 1. So, secant 0 is also 1, 2 minus 1 is 1. So, definite value of the definite integral. This problem also come under basic method in indefinite integration, only limits are there. So, in the to write this as a definite integral. Now, I am going to consider some more problems of different type, some more problems of different type on definite integration. So, problems. Problem number 11, 0 to pi by 2, cos x divided by 1 plus sin square x, 1 plus sin square x dx. 12th problem, pi by 4 to pi by 4 to pi by 2 cot square x dx. Problem number 13, 0 to pi by 2 x cos x dx. 14th problem, integration 0 to 1 tan inverse x whole square by 1 plus x square dx. Problem number 15th, that is 0 to pi by 2, 0 to pi by 2 1 by 1 plus tan x dx. 16th problem, integration of 0 to pi by 2 sin cube x dx. Problem number 17, integration of 0 to pi by 2 sin 3x cos x dx. 18th problem, 18th problem, 0 to pi by 2, 0 to pi by 2 sin power 5 by 2 x divided by sin power 5 by 2 x plus cos power 5 by 2 x dx. So, note down these problems. So, how to work out problems? So, these are the problems of different type, that is substitution method, integration by parts, etc., etc. So, consider one by one. Problem number 11th, I is equal to 0 to pi by 2, 0 to pi by 2 cos x divided by 1 plus sin square x dx. See here. So, numerator is cos x, denominator is 1 plus sin square x, sin x differential coefficient is cos x numerator. This is of the type, this problem can be solved by substitution method. Now, the denominator derivative is numerator, therefore, this problem come under the type f dash x divided by f of x dx. So, derivative of denominator is numerator. So, therefore, problem under come under this type f dash x by f of x. Now, take the substitution. So, put sin x is equal to t. So, put sin x is equal to t. Now, cos x is equal to dt by dx. Cos x is equal to dt by dx. Or we can write this as cos x dx, cos x dx is equal to dt. See here, we can also change the variable, we can also change the limits after changing the variable from x to t. So, this is also possible. Now, if x is equal to 0, when x is equal to 0, so now I am going to change the limits also here. So, in the last problem, so I work out the problem by considering same limits, upper limit and lower limit, no change. So, that is because of the property, by changing variable of integration x to t, the value of the integral remains same. Now, when x is equal to 0, when x is equal to 0, t is equal to sin 0. Put x is equal to 0, sin 0 is 0. So, the lower limit, when you take x is equal to 0, t is equal to sin 0 value is 0. So, this is lower limit. When x is equal to pi by 2, upper limit, when x is equal to pi by 2, so t is equal to sin pi by 2, sin pi by 2. So, that is equal to sin 90 value is 1. Therefore, the limits 0 to pi by 2 change to limit t is equal to 0, t is equal to 1. And also the variable x changes to t. Therefore, this method is also called as change of variable method. Now, the given integral becomes change the limits also. So, instead of 0, that is x is equal to 0, t also equal to 0. When x is equal to pi by 2, t is equal to 1. So, limits changes from x to pi by 2 to 0 to 1. Now, what is cos x dx? Cos x dx is dt divided by 1 is a constant, right, as it is, sin square x, sin x is t, sin square x is t square, that is 0 to 1 dt by 1 plus t square. So, that is equal to, so 1 plus t square integration 1 by 1 plus t square with respect to t, that is tan inverse t, that is tan inverse t between the limits 0 and 1. So, now upper limit, that is tan inverse 1 minus lower limit tan inverse 0. So, we can also do the problem without changing the limits, keeping the given limits as it is. Also another method, that is by property. So, we can also change upper limit, lower limit after taking the substitution or after taking the variable x to t. Now, what is tan inverse 1? Tan inverse 1 is nothing but pi by 4. How to find out tan inverse 1 value? See here, Suppose if you write x is equal to tan inverse 1, by definition tan x is equal to 1. Tan x is equal, that is by definition, if you take x is equal to tan inverse 1, by definition of inverse trigonometric function tan x is equal to 1. So, which angle corresponds to 1 in tan function, that is tan 45 is equal to 1, tan 45. Now, equation is tan x is equal to 1 is equal to tan 45. So, x is equal to 45 or pi by 4 in terms of radians. So, tan inverse 1 is pi by 4. What is tan inverse 0? See here, x is equal to tan inverse 0, x is equal to tan inverse 0 or tan x is equal to 0, that is nothing but tan 0. The value of tan 0, sin 0 by cos 0, 0 by anything is 0. So, x is equal to 0. Therefore, pi by 4 minus 0 is equal to pi by 4. This is the definite value of the given definite integral. Now, problem number 13, 11 and 12 over. Problem number 13. See here, integration between the limits 0 to pi by 2, between the limits 0 to pi by 2 x cos x dx. So, this problem, product of two functions are there, product of two functions, one function is x, another function is cos x. So, which method to adapt to work out or to integrate x cos x, that is integration by parts method, integration by parts method. So, what is the formula to integrate the given integral by parts method? So, observe the formula, integration of f of x q of x dx is equal to product of two functions, f x is one function, q of x is another function. The function selected for differentiation is f x, function selected for integration is q of x. Now, f of x into integral of q of x dx minus integral of f dash x into qx dx whole dx. So, this is the formula. So, this is the formula to, that is product rule in integration. This formula is product rule in integration. Apply this formula to integrate product of two functions in the integrand. So, first function select for differentiation, cos x select for integration. Why? Because if you differentiate x, you will be getting 1 in the next step. Suppose if you select in reverse process, that is cos x for differentiation, this is for integration, you will be getting x square by 2 cos x integration sin x etc. It will continue, no solution. So, therefore, x for differentiation, cos x for integration. After integration process is over, apply lower limit, upper limit. See here, keep the function selected for differentiation as it is, that is x. Integrate the second function, that is cos x dx minus integral of d by dx of the first function, that is derivative of the first function, into integral of the second function whole dx. If you write this step, then it is very easy to follow. X into integration of cos x with respect to x is sin x, x sin x minus d by dx of x, d by dx of x is 1 into integration of cos x is sin x dx, sin x dx, that is equal to x sin x minus 1 into sin x is sin x dx. Between the limits, write flower bracket 0 to pi by 2. So, or we can write here 0 to pi by 2. In all the cases, you must write the limits, that is 0 to pi by 2. here also 0 to pi by 2. Now, first term is x sin x. Sin x integration is minus cos x. Sin x integration is minus cos x, minus into minus plus cos x between the limits 0 and pi by 2. Now, integration process is over. In examination, you will be getting 4 marks for up to this stage. You will be getting 4 marks up to this stage, and applying limit carry only 1 marks. So, integration process or integration part is more important, therefore, they will give more important or more weightage to integration process, then applying limit, that is high school process. So, that carry only 1 mark. Now, so write upper limit is pi by 2, x is pi by 2 sin pi by 2 plus cos pi by 2, this is upper limit. Pi by 2 sin pi by 2 plus cos pi by 2, put x is equal to pi by 2. Now, minus lower limit. What is lower limit? Lower limit is 0. So, put x is equal to 0, 0 into sin 0 plus cos 0, this is lower limit. Now, pi by 2 sin pi by 2, that is sin 90 value is 1, sin 90 value is 1, cos pi by 2 is 0, cos 90 is 0, close the first big bracket, minus 0 into anything is 0, sin 0 is also 0, 0 into 0, cos 0 is 1, so cos 0 is 1, that is equal to pi by 2, so this is 0 minus 1. So, this is the value, or we can also write this as the LCM is to pi minus 2. So, pi minus 2. So, pi minus 2 by 2 or pi by 2 minus 1. So, this is the value. This problem come under integration by parts method. Uh, 14th problem, inverse trigonometric functions are there. Inverse trigonometric function, that is 14th problem. I is equal to 0 to 1, 0 to 1 tan inverse x whole square divided by 1 plus x square dx. So, the problem can be solved or can be integrated by substitution method. Substitution method means you must remember 4 forms come under substitution method. So, check whether this problem come under first, second, third or fourth form. So, this problem is of the type, see here, differentiation of tan inverse x is 1 by 1 plus x square. So, therefore, this is of the type f of x divided by f dash x dx. So, this problem come under f of x divided by f dash x. If you differentiate numerator, you will be getting denominator. Therefore, take the substitution for f of x. Take the substitution for f of x. What is f of x? Tan inverse x. So, put tan inverse x is equal to t. Put tan inverse x is equal to t. Now, differentiation of tan inverse x with respect to x is 1 by 1 plus x square is equal to dt by dx, dt by dx, or we can write this as, 1 by 1 plus x square dx is equal to dt. So, 1 by 1 plus x square dx is equal to dt. Now, the given integral becomes after changing the variable x to t, that is change of variable method. Now, 0 to 1 tan inverse x is t, tan inverse x whole square is t square, 1 by 1 plus x square dx is dt. So, 1 by 1 plus x square dx is dt, this is t square dt. Integrate t square with respect to t, so we get t cube by 3, so between the limits 0 to 1. 1 by 3 is a constant, take it outside. So, 1 by 3 is a constant, take it outside. Now, what is t? T stands for tan inverse x, t stands for tan inverse x whole cube. So, tan inverse x whole cube. So, 1 by 3 is a constant. Now, 1 by 3 into write first small bracket, or there is only one term, apply the limit directly upper limit. So, upper limit is 1, upper limit is 1. So, tan inverse 1 whole cube minus tan inverse 0 whole cube, close the bracket. Now, 1 by 3 into what is tan inverse 1? So, I already explained, x is equal to tan inverse x, tan x 1 is equal to tan 45, x is equal to 45, or in terms of radians pi by 4. So, we get pi by 4 whole cube minus tan inverse 0 is 0. This is equal to 1 by 3 into pi by 4 whole cube, that is pi cube, 4 into 4 into 4 64. So, 1 by 3 into pi cube by 64. So, that is equal to pi cube divided by 64 into 3. So, that is 192. So, 60 into 3, 4 into 3, 192. So, this is the definite value, no constant, because this is definite integration. So, this problem solved by substitution method, and the type of this problem is integration of f of x by f dash x. Next problem, 15th problem. 0 to pi by 2, 1 by 1 plus tan x dx. See here. So, I am going to apply one property. So, to work out this problem, so what is that property? So, that I am going to explain now. See here, the property is 0 to a, f of x dx is equal to 0 to a, f of a minus x dx. So, this property I am going to use in this problem. Now, this can be written as 0 to pi by 2, The LHS is I is equal to, 15th problem, given I is equal to 0 to pi by 2, 1 by 1 plus tan x dx. Now, 1 divided by 1 plus, how to write tan x in terms of sin? So, write tan x as sin x by cos x dx, sin x by cos x. See here, so 0 to pi by 2, so LCM in the denominator is cos x, numerator is cos x plus sin x. So, totally that becomes cos x plus sin x, dx. See here, LCM is cos x, take this cos x to the numerator cos x, here cos x plus sin x. So, LHS is I, that is given integral. Call this equation 1, Now, apply the property 0 to a, if the lower limit is 0, we can apply the property, that is 0 to a f of a minus x dx. So, now this is equal to, this is also I, 0 to pi by 2, 0 to pi by 2 cos of pi by 2 minus x divided by cos of pi by 2 minus x plus sin of pi by 2 minus x dx. Now, using the property 0 to a, that is 0 to pi by 2 x minus pi by 2 x. This is equal to 0 to pi by 2, 0 to pi by 2. See here, cos of 90 minus x, first quadrant all t functions are positive, 90 minus theta first quadrant, cos of pi by 2 minus x first quadrant, cos changes to sin, divided by cos pi by 2 minus x sin x plus cos pi by 2 minus x is cos x dx. So, this is also I. Call this equation 2, Now, adding 1 and 2, so adding 1 and 2, see here, adding 1 and 2, one equation LHS is I, second equation LHS is I. First add LHS of both equations 1 and 2. I plus I is 2I, between the limits 0 to pi by 2. Now, cos x plus sin x, denominator cos x plus sin x, LCM is same, that is sin x plus cos x, numerator is cos x plus sin x or sin x plus cos x dx. So, 2I is equal to 0 to pi by 2 sin x plus cos x divided by sin x plus cos x. So, this is equal to 0 to pi by 2, see here sin x plus cos x by sin x plus cos x is 1 into dx, that is nothing but dx. Now, how to simplify this? Now, 2I is equal to integration of x, integration of 1 with respect to x, that is variable of integration. See here, if you differentiate x with respect to x, you will be getting dx, differentiation. Integration of dx is x, this is reverse process. So, x differentiation is dx, dx integration is x. So, integration of dx is x between the limits 0 to pi by 2, Now, this is equal to apply upper limit. What is upper limit? Pi by 2 is upper limit, pi by 2 minus lower limit is 0, pi by 2 minus 0 is pi by 2. This is the value of 2I. We want only the value of I, that is I means given integral. Now, I is equal to 2I is equal to pi by 2, I is equal to pi into 2 by 2, this 2 go to the denominator. So, that is equal to pi by 4. So, this is the value of the given integral 0 to pi by 2, 1 by 1 plus tan. I apply the property, that is 0 to a f of x dx is equal to 0 to a f of a minus x dx. So, in the last class I explained the property, by changing the variable from x to t, the value of the integral remains same. Here I explained another property. I will explain this property once again by taking one more example of the type. Now, problem number 16. I is equal to 0 to pi by 2, sin cube x dx. See here, same problem I considered in indefinite integration. So, this problem solved in that method using multiple angle formula. Now, I am going to use another method to integrate sin cube x and limit upper limit pi by 2, 0 lower limit. See here, So, we can write this as 0 to pi by 2 sin cube x can be written as sin square x into sin x dx, sin square x into sin x dx, sin cube x, or we can write this as 0 to pi by 2, 0 to pi by 2 1 minus cos square x into sin x dx. So, sin square x can be written as 1 minus cos square x sin x dx. Now, if you take the substitution for cos x, if you take the substitution for cos x, you will be getting minus sin x. So, if you differentiate first function, you will be getting second function. Therefore, this is of the type f of x f dash x dx, that is derivative of the first function is second function. Therefore, take the substitution for cos x. So, put cos x is equal to t, put cos x is equal to t. Now, differentiate minus sin x is equal to dt by dx. Differentiation of t with respect to x is dt by dx, LHS is minus sin x. We want sin x, or we can write this as sin x dx is equal to minus dt. Sin x cross multiplication dx, transfer minus to that side, sin x dx is equal to minus dt. Now, I am also changing the upper limit and lower limit after changing the variable from x to t. Now, see here what is the procedure. When x is equal to 0, when x is equal to 0, t is equal to, now take the limits, that is by changing variable x to t. If x is equal to 0, t is equal to cos 0, x is 0, cos 0 is 1. Therefore, lower limit 0 changes to 1. Similarly, second upper limit, that is x is equal to pi by 2, t is equal to cos of pi by 2, cos of pi by 2 is 0. So, 0 to 1 changes to 0 to 1, that is 0 to pi by 2 changes to 1 to 0. Now, the given integral is equal to, 0 means 1, 1. What is pi by 2? Pi by 2 is 0. Now, 1 minus cos x is t, cos square x is t square, sin x dx is minus dt. If there is minus sign, write the bracket. So, this is equal to minus is a constant, take it outside. Instead of minus, we can also write minus 1. Minus 1 into 1 to 0, 1 minus t square dt. So, minus is a constant, take it outside. So, instead of minus, I am writing minus 1. So, minus 1 into apply upper limit, that is upper limit is 1 minus t is 0, 0 square is 0, minus lower limit 1 minus, so 1 square is 1, close the bracket, that is equal to minus 1 into 1 minus 0, 1, 1 minus 1 is 0, 0 into minus, that is answer is plus into minus, minus 1. So, here I changed both the variable and also limits. If you change the variable x to t or t to x, the value of the definite integral remains same, that is property number 1 that I explained in the last class. And also I work out the same problem, that is sin cube x in indefinite integration using the concept of multiple angle formula, that is sin 3x is equal to 3 sin x minus 4 sin cubed x. So, problem number 17th problem. 17th problem, 0 to pi by 2, 0 to pi by 2, sin 3x cos x dx. See here, this is product of two trigonometric functions are there, one multiple angle and another cos x. Multiple of two trigonometric functions are given in the integrand. Now, this can be solved by transferring product into sum or difference of functions, product into sum or difference of functions. Which formula to be used? See here, 2 sin A cos B, 2 sin A cos B is equal to sin of A plus B, sin of A plus B plus sin of A minus B formula. Transformation formula from product of two functions into sum of two functions, sin A cos B. So, that is equal to sin of A plus B plus sin of M. We want only sin A cos B. Sin A cos B is equal to, take this off to the RHS, that is half into sin of A plus B plus sin of A minus B, close the bracket. Now, sin 3x cos x, sin 3x cos x is equal to, now A is equal to 3x, B is equal to x, substitute in the formula, half into sin A plus B 3x plus x 4x plus sin A minus B 3x minus x is 2x. So, I transfer product of two functions, that is sin 3x cos x is nothing but half into sin 4x plus sin 2 into becomes plus. So, that is equal to the given integral I is equal to, half is a constant right outside the integral sign, 0 to pi by 2, half into integral 0 to pi by 2 sin 4x plus sin 2x whole dx. Now, integrate term by term, integrate term by term. After integration, apply upper limit and lower limit. Half is constant, applies for both the terms. So, that is half into sin 4x integration. See here, integration of sin mx, integration of sin mx is equal to mx dx is equal to minus cos mx by m plus c. Integration of product that is multiple angle sin mx dx is equal to minus cos mx by plus c, that is minus cos 4x by 4 minus cos 2x by 2. Here m is 4, here m is 2. So, between the limits 0 and pi by 2. So, now half into right big bracket, in the first small bracket apply upper limit and in the second small bracket apply lower limit and close the bracket. Now, apply upper limit pi by 2, see here, minus cos 4 into pi by 2, 4 into pi by 2, 4 into pi by 2 by 4 minus cos into 2 into pi by 2 by 2, this is upper limit. Now, apply lower limit, minus 0 into anything is 0, cos 0 by 4 minus, here also 0 into 2 is 0, cos 0 by 2. Now, this is equal to half into 2 divides 4 2 times, that is 2 pi, cos 2 pi, see here. So, this is 0 degree, this is 0 degree. So, 90, 180, 270, again 360 is same as 0 degree. Here 2 pi means 360, 360 degree is same as 0 degree. that is cos 0 degree. Cos 0 degree is 1 by 4. See here, I explain once again. 4 into 5 by 2, 2 divides 4 2 times 2 pi. 2 pi degree is nothing but 0 degree. 2 pi after completion of one round, 2 pi degree is nothing but 0 degree. Cos 0 is 1 minus 1 by 4. 2 cancel, 2 cancel. Cos pi value I already explained in the last case, that is cos pi is equal to cos 90 plus 90, cos second and third quadrant, that is minus sin 90, that is equal to minus 1. So, 2 divides 2 cancel, cos pi is minus 1, cos pi is minus 1, minus of minus plus 1 by 2. So, this is first small bracket inside the big bracket, minus 1 by 4, minus 1 by 4, cos 0 is 1, that is minus 1 by 2, close the big bracket, that is equal to half into minus 1 by 4 plus 1 by 2, minus into minus plus 1 by 4, minus into minus half, close the bracket, 1 by 4 cancel, half into half plus half is 1, that is equal to half. This is the value of given definite integral. So, one more problem is there. So, in that problem, so I am going to apply the limit, that is the second property. Powers are there for trigonometric functions. So, 18th problem, I is equal to 0 to pi by 2, 0 to pi by 2 sin 5 by 2 x, sin power 5 by 2 x divided by sin 5 by 2 power x plus cos 5 by 2 x dx. So, call this equation 1. I is equal to sin power 5 by 2 x, sin power 5 by 2 x plus cos power 5 by 2 x. So, apply the property. Now, what is the property? See here, 0 to a, f of x dx is equal to 0 to a, f of a minus x dx. So, apply this property. Now, I is equal to 0 to pi by 2 sin of pi by 2 x means pi by 2 minus x, pi by 2 minus x, pi by 2 is the upper limit, divided by sin power 5 by 2 x means pi by 2 minus x plus cos to the power of 5 by 2 x means pi by 2 minus x dx. So, I is equal to 0 to pi by 2 sin power 5 pi by 2 minus x, pi by 2 minus x is 90 minus theta, 90 minus theta first quadrant. So, see here, observe this figure, all students take coffee, all functions are positive in the first quadrant. Here pi by 2 minus x, pi by 2 minus x, pi by 90 minus theta. So, all come under first quadrant, all t functions are positive. Now, sin power 5 by 2, so that is pi by 2 minus x, that is 90 minus theta, function is positive, function changes from sin to cos function, that is cos power 5 by 2, so x, cos power 5 by 2 x divided by Here sin power 5 by 2 90 minus theta first quadrant, sin changes to cos, cos of 5 by 2 x plus cos 90 minus theta sin, sin to the power of 5 by 2 x, variable of integration is dx. Equation 1 and equation 2. Equation 1 given problem, equation 2 after applying property, that is 0 to a f of x dx is equal to 0 to a f of a minus x dx. Now adding 1 and 2, adding equation 1 and equation 2. First add LHS, I plus I 2i, I plus I is equal to 2i, 0 to pi by 2. See here, this denominator is same as this denominator, sin power 5 by 2 plus cos power 5 by 2 x. So, you will be getting same thing, cos power 5 by 2 x plus sin power 5 by 2 x, both bases are same in both equations 1 and 2. Add, that is numerator of equation 1, that is sin power 5 x by 2, sorry, sin power 5 by 2 x plus cos power 5 by 2 x. So, variable of integration is dx. So, this is equal to, so 2i is equal to, 2i is equal to 0 to pi by 2, 0 to pi by 2. So, numerator and denominator is same, numerator and denominator is same. On simplification, you will be getting 1 dx. 2i is equal to 0 to pi by 2, 1 dx. Integrate 1 with respect to x. So, that is integration is x, 1 with respect to x is x, that is equal to 0 to pi by 2. Now, apply upper limit minus lower limit. 2i is equal to, 2i is equal to, upper limit is pi by 2 minus lower limit is 0. So, put x is equal to pi by 2 for the upper limit, put x is equal to 0 for the lower limit. So, 2i is equal to pi by 2 minus 0 is pi by 2. So, the value of 2 integral, that is 2i is equal to pi by 2. We want the value of 1i, that is given integral. So, I is equal to pi by 2, this 2 goes to the denominator, that is equal to pi divided by 4. So, the value of the definite integral, the powers are there for the trigonometric functions. So, value of this definite integral is pi by 4. So, this is the procedure to work out problems. Only difference between definite and indefinite integration. Indefinite integration, integrate by any method. There are 3 or 4 methods I explained. If it is definite integral, apply the same procedure to integrate the given integrand. After integration process is over, apply upper limit and minus lower limit. So, this completes almost definite integration chapter. So, in the next class I am going to explain applications of definite integral. There are 3 applications: area, volume of solid of revolution, and RMS value, that I am going to take up in the next class. Thank you one and all.